moves from A to B. Moves from A to B. The force is 2 Newton between A and B as shown. Point A and B is 1.5 meter apart. We know the kinetic energy at A is 5, at B is 4. How much work is done on the block by the force of friction? It's the same as 4 and 7. This question is the same. Analyze the energy. How much work is done by the force? It should be the force times cosine 40 degree times the distance, which is 1.5 meter, right? That's the work done by this force, and plus the work done by this force. It should be, if we put the initial energy plus the work, should be equal to the energy at B point. Right, that's the equation. You put the initial, the work is equal to the energy in the end. And if we plug in the numbers, that's 5 plus P is what? P is 2. Is equal to 4. Equal to 4 minus 5, negative 1, 3 times cosine 40. And then if you calculate it, it's negative 3.3. This question. You have any questions? So you continue to study, you can study these 3 together. There are similar questions. You kind of reinforce this concept. The energy is always equal. In chemistry, in physics, you always use this concept. So, for example, a system, whatever system, you have the initial energy, you have the work, whatever work acting on this object, the acting work, and in the end, you got the resultant energy. It should be equal, because the energy won't go somewhere else, it will stay within this system, right? And that's number 9. And number 10. A 2 kilogram block slides down a fractionless incline from point A to B. A force, which is 3 Newton, acts on the block between A and B. And but you know it's Going down.
Going down, yeah.
Points A and B are 2 meters apart. If kinetic energy of the block at A is 10, what's the kinetic energy of block at B? Okay. So first analyze along this line. There's also a component of the gravity, right? So analyze the resultant force. This gravity will be times 9.8 times sine 30 minus this force. That's the resultant force, right? Which is going down. And it should be, if you calculate, it's 9.8 minus 6.8 Newton. So when you analyze all the force along this line, you find the resultant force is 6.8 Newton going down. Okay? And the distance is 2 meters. So the work of the total force will be 6.8 times 2 meters, which is 13.6. And because we know the initial energy at B will be initial plus the work of the total force should be 10 plus 13.6, which is 23.6. Do you understand each step?
We had to first calculate the force,
Yes.
which we did, and then
You
it was
can-
6.8 times
there are
the
two ways. There are
displacement.
2 ways to calculate. You can calculate the work by this force, the work by the friction, by this force, and the work by the work of the gravity, and then add them together. It's the same thing. Or you can calculate the total force first, and then calculate the work.
So adding them together would be 6.8 newtons.
Yes.
And then you would do, the force would be 6.8 times the displacement,
2 meters.
and it's cosine of, it would be cosine of 0, right?
Yeah, there's
Because
no,
it's going in the
yeah,
same
the
direction.
same direction.
So the angle would be 0.
Yeah.
So that's how you have 13.6.
13.6.
And then you would do the energy initial plus 13.6.
Yes. Which is 23.6.